Okay, so today's session is based on chapter 8. It's just a revision on chapter 8, and I'm also going to do a revision on chapter 10, right? So, chapter 8, right? Chapter 8, right? Chapter 8 is based on inferential statistics, inferior stats. What does that mean? It means that you're making conclusions based on the population using the sample, right? So inferior stats means that you're making conclusion from the sample based on the whole population. So you've got a population. Within a population, you've got things called parameters, right? These parameters can be your mu, your proportion, or your variance, right? These are called parameters. Right? Then obviously in chapter 8 these are known, and sometimes they can be unknown. Okay? So you want to make conclusions from what you calculate based on the sample, which is statistic. Sample. So in a sample, you've got things called statistic, and these statistics are estimates of the parameters. So you've got your x bar, and you have your p hat, so you have your variance hat, right? These are estimates of these unknown parameters, right? So if you want to make conclusions, every time if you making conclusions based on things you calculated on the sample, you're making conclusions about the population, you need to understand that you're dealing with inferior statistics. Okay? Now, chapter 8 is based on hypothesis testing. Hypothesis testing, right? What is an hypothesis test? An hypothesis test, these are claims, these are assumptions, right? These are assumptions you believe or you claim from the population, from the information given on the population, right? So these are claims made from the parameters. So in chapter 8, these are known, right? These are known. So where do you start? Obviously, if you're making a claim, you will start by an hypothesis test, which is H naught. This is referred as being the null hypothesis, right? And you've got H1 or HA, which is referred as being the alternative. Hypothesis, right? So your hypothesis testing, can be of your average. So you've got average, you've got proportion, you also have your variance, right? So your hypothesis testing can be between these three parameters. It's based on average, proportion, or variance, right? So we always assume, every time you do a hypothesis test or an assumption, you always assume your null hypothesis is true, right? So what does that mean? It means that your H naught is equals to, right? I mean, in most cases, you always assume your null hypothesis is true, okay? Then you've got your alternative, which is HA or H1, right? So your alternative, now these are your claims, these are your beliefs. It can be the fact that you believe that your null hypothesis is not true, or you claim that it's higher than the average that you're given if your hypothesis test is based on average, or it's higher than the proportion if your hypothesis test is based on proportion, or it's higher than the variance from the population, then your HA, which is your alternative hypothesis, will be greater than, right? Remember, this information is taken from the population. Right? Okay? It's either your alternative is greater than, or else is less than, or else is not equals to. Right? Okay. Can it be equals to? It can't be the same as your null hypothesis, because why are you doing the hypothesis test if it's true? Right? So it's either you're dealing with a one-tailed test. These are called one-tailed test. Right? Hypothesis test based on one-tailed. And this is your two-tailed test. So this is two-tailed test. Right? This is where, so now let me give you a tip. This is where you see or identify. Identify your rejection region or your critical region. Or your critical region. Region. Right. Okay. Then from here, obviously these are unknown, so your claims or your beliefs, you're making them based on the known parameters, right? So the next step is calculate your test statistic, right? Test statistic. Okay? So we both agree that your hypothesis test can be either based on average, proportion, or variance, right? That goes also with your test statistic. Your test statistic must be in line with your hypothesis test. If your hypothesis test is based on average, it means your test statistic must be based on average. If it's based on proportion, then it means your test statistic must also be calculated using proportions. If it's based on variance, it means that your test statistic must also be calculated based on your variance, which is your chi-square. Okay? Now, remember, you've got these, and these are calculated based on the population, right? They are known, right? And these are constant, right? And you're making your claims from the known information, which are these parameters. So obviously, if you make your claims, you can't make your claims based on you can't get information based on the whole population. So you need to get your sample, and from your sample, you calculate your test statistic. So these are your statistic, right? Okay. Then if your hypothesis test is based on average, your test statistic is either Z0 is equals to X bar minus nu over the square root over the standard deviation of the population divided by the square root of n, right? This is the standard error, right? All the time you must include the standard error if whatever you calculate, because now you want to make conclusions based on the population using the sample. So the error, you must conclude it, right? This is the population parameter. This is the population parameter. What is this? This is the standard deviation of the population. Right. So you can only use this to calculate your test statistic if the population of the parameter is known and your n is greater or equals to 30, right? This is the first formula to calculate your test statistic. The second formula is called T naught, T distribution, right? It's also x bar minus mu divided by S, which is the standard deviation calculated based on the sample, all over the square root of n, right? Also, this is known as the standard error. So, what is this? This is a statistic, right? Estimate. This is the standard deviation of the sample, right? Okay? So these two are the test statistic if your hypothesis test is based on average, right? Now, what if your hypothesis test is based on proportion? Now, this test statistic for an hypothesis test of proportions is Z naught is equals to X bar, not X bar, P hat minus the true proportion divided by the square roots of P naught, 1 minus P naught all over square root of n. Again, this is the standard error. Okay, right? This is the test statistic if your hypothesis test is based on proportions. Okay, what is P hat? In most cases, you'll need to calculate your P hat as being R divided by N, right? All this information you'll be given in your statement of hypothesis test. Then what if your hypothesis test is based on variance, right? The test statistic will then be n minus 1 s squared divided by, this is the standard deviation based on the sample. This one is the standard deviation based on the population, right? You can only use this one if your n is less than 30 and your variance is unknown, right? When will variance be unknown? Variance will be unknown if you're not being told in the population. If you are not told about the variance in the population, then variance is unknown. So if I can give you the standard deviation in the population, it's the same thing as if I'm giving you the variance. So variance is known, right? Okay. Then when do you use this one? You can only use this one if your hypothesis test is based on proportions, right? Then this is the test statistic to use. Your P hat is equal to R divided by N, right? If your hypothesis test is based on variance, then you use this formula here, right? Now the third part, so this is the first part. The first part, construct your hypothesis test, meaning you need to tell us your H0, your H1. The second part, you need to calculate your test statistic. The third part is find your critical regions. So this is the second part. Now the third part. The third part, critical regions. Regions or your rejection regions. Right, rejection regions, right? Now, your critical region must be in line with your test statistic, must also be in line with your hypothesis test, right? So there are three critical regions we'll look at. The first one is a distribution called anomaly distribution, right? The second one is your T distribution. Then the third one is your chi-square distribution, which is positively skewed, right? Listen, guys, you've got Z naught here, right? What is Z naught? Z0 is for something which is standard normal, right? Normal distribution, right? You also have Z0 here, right? Meaning if your test statistic is conducted using your Z0, right? These Z0 formulas, that means your critical region or your rejection region must be on the normal distribution curve, right? So this is called normal distribution curve. I mean, it's bell-shaped, right? Now, the second one, if your test statistic is based on T, right? You've used T distribution to calculate your test statistic. Now, when are you going to use this one? If your n is less than 30 and your variance is unknown, right? Now, question is, what if your variance is known and n is less than 30? What do you use? Variance is known, but n is less than 30. What do you use? Z, right? Z0, the first one, right? So you need to understand, if you're given a statement based on hypothesis testing, the first thing you ask yourself is variance known or unknown, right? If it's known, this guy. If it's unknown and your n is less than 30, this, right? Okay, so if your test statistic is calculated based on the T distribution, so obviously your critical region or your rejection region will be based on the T distribution. So T distribution, right? Curve, which is this one, right? It's also under the normal distribution curve. What makes the T distribution curve different from this is the fact that this only deal with sample which is less than 30 and the variance is okay, fine, it's unknown, but remember, for normal distribution curve the variance is equal to 1, right? For a normal distribution curve. For this one, since if you look at this curve, it's a bit more slim. What does it mean about the T distribution curve? The variance for it's greater than 1, right? Because if you increase your variance, this shape of a bell shape will become slim, right? Okay, and then if your test statistic is based on your chi, right? What does it mean? Your rejection region or your critical region will be under the chi-square distribution. Right? Okay. This, you can't find this if you don't know this. Can't find this if you don't know this. Right? Just 3 steps. You're doing an hypothesis test. The first thing you need to do, what is your hypothesis testing? The second thing you do, what is your test statistic? The third thing you do, what is your critical region or your rejection region? Okay? So now then from there, each distribution has 2 sides, right, of rejection. It's either the left-tailed, right, or your right-tailed side, right? Even this one has this side and also this side, right? This one is this side and also this side. Mfundisa normal na makamera ne? No, ngiyayibona nami ngiyayibona. So okay, what's on the middle, right? What's on the middle, right? So if your null hypothesis test, your hypothesis testing is based on average. Remember, these are parameters. These are things calculated based on the population. So if these known parameters, you want to estimate them, these are true parameters, right? So they're here, right? It can be either, it's always mu with this one, right? For variance, in the middle, right? So this is where you don't reject your H0, this piece, right? And this area under this normal curve is referred as being 1 minus alpha, right? Right. 1 minus alpha. right? So where do you reject your H naught? If your test statistic lies within your alphas, your alpha, right? So alpha is this area or this area, right? But also your rejection region depends on your alternative hypothesis, right? So if your alternative hypothesis, I send you guys a pic on WhatsApp, right? On our group. So if your alternative hypothesis test, it can be either mu proportion, mu is average proportion, or variance. If it's greater than, what does this mean? It means that your rejection region is on the right, right? Right. If it's mu here, it means that your rejection region is either this or this. But you can only use this if variance is known and n is greater than, which is the sample is greater than 30. You can only use this if variance is unknown and n is less than 30, right? But what must click into your mind is the fact that your critical region is on the right. So it's in this side or this side, right? Also, what you must pick out is the fact that if your rejection region is on the right, it means your test statistic must be positive. Right? Right. Okay. So your test statistic, it can be either this, or this if your rejection region is based on the normal distribution curve, right? So what if you're dealing with P? P is greater than. Now remember, you can never have H naught or your alternative hypothesis based on your statistic. So you can't have P hat here. You can't have X bar here. You can't have variance hat here, right? These are all parameters, okay? Then let me write this rejection side. Here, this side you've got Z alpha by 2. This side you've got 1 minus alpha by 2. This side is T n minus 1 degrees of freedom and alpha. This side is it's also T n minus 1 minus alpha, right? Then you've got this side now. This side is chi degrees of freedom n minus 1 alpha by 2. Alpha. Then this side you've got chi again n minus 1 and 1 minus alpha, right? So you've got your H naught, you've got your alternative, right? This is always true. If H1 is greater than, it means that your rejection region is on this side, right? What if your alternative is less than? It means your rejection region are on this side, right? You're dealing with a one-tailed test. It means there's only going to be one side where you reject your H naught, right? Remember, why your aim is H naught? It's because the moment you do this hypothesis test, you're trying to disagree with what's on the population, your H naught, right? So that's why your focus, when concluding, is based on your null hypothesis, whether you reject H naught or you do not reject H naught, right? Okay. Then if your H1 is less than, it means your rejection region is within these entails. Okay? We'll do questions just now. Then, what if it's your two-tailed test? What if it's not equals to? It means that your rejection region lies within this, the left-tailed and the right-tailed, right? Okay. Now let's make a rule. I will reject H naught if my test statistic is, put a box here, critical region. Right? Or rejection region, right? So what you put here, it's everything that is on your alternative hypothesis. If it's not equal to here, so this means this box will have not equal to. If it's greater than here, less than here, right? Okay, are you guys with me? Okay. Then obviously, I mean, guys, you making conclusions on something you calculated on the sample. You're making conclusions about the population. Obviously, there's gonna be an error, right? Then you've got type 1 error and type 2 error, right? What is type 1 error? So I sent you guys a nice pic, right? Decision on the sample, right? Then decision on the population, right? You've got reject. Is it reject H naught here? Right. Reject H naught. You've got accept. Is it accept here? Yes. Accept H naught. Right. You've got H naught true here. Right. You also have H1 true. Is it true?
Yes.
Okay. This is so nice. So nice, eh? Ningahle nimsmilele lo bhuti lo baya shoes. So oh, come on. Okay, so when is type 1 error? Type 1 error, it's when you reject H naught, but H naught is true, right? So it's when you reject H naught, but H naught is true. Type 1 error. Type 1 error. Right? Right. Now, what is type 2 error? Is when you... Yeah? When you accept H naught while H naught is false, right? So, why is that the case? You're doing a hypothesis test, right? So if you're doing an hypothesis test, obviously you've got parameters that where you're doing your hypothesis test from. So if, let's say, you reject your H naught while H naught is true, that means you've made an error, right? What if you do not reject H naught while H naught is false? That means that's another error. That's a type 2 error, right? So that's when you accept H naught while A is true, right? So this is type 2. Right. So, yeah, this is your chapter 8, actually. Type 1 error, type 2 error, you know how to calculate your test statistic, you construct your hypothesis test, your rejection region. It's either a normal distribution or T distribution or the chi distribution curve, right, which is positively skewed. Then, can we do questions? That's our reference paper, 2015 semester 1 main exam, right? Let's look at that. Yo, guys, this is beautiful. Okay, so right, so now, okay, now questions. Let's just look. It's a question that we've been doing for some time now, but yeah, exam, right. So if you scroll down. So if you scroll down, semester 2015 semester 1 exam. So if you scroll down up until question, which question? Question, is it, let me see. Question 34, right? So if you look at question 34, are you guys looking at question 34? This is a question based on hypothesis testing, right? Now, why is it a question based on hypothesis testing? I mean, you're given a paragraph, and this paragraph you're being told that you want to do or conduct an hypothesis test, which is okay. I mean, what does that mean to you? This is the beginning of chapter 8, right? Okay, so what is the statement? Due to the electricity supply problems, it is important to pay attention to the amount of electricity we're using. The electricity provider claims, right? The electricity provider claims that the average annual kilowatts usage of residential customers is this, and the standard deviation is this. Now, what is important here is variance known or unknown? Yeah? It's known. Why? Because you're being told the standard deviation based on the population, right? If that's the case, if the standard deviation is based on the population, that's the same thing as giving you the variance. So variance is known, right? So what must click into your mind, you'll use this formula no matter whether n is less than 30, right? Why is that the case? Because variance is known. Okay? So you can't answer question 34 without conducting your hypothesis test, your test statistic, then your rejection region. So you believe that the mean usage is higher than this, but the standard deviation is correct. A random sample of 30 residential customers give a mean kilowatt usage and the standard deviation. Using the information, you do an hypothesis test where now you give an alpha to confirm your beliefs. Okay, so what is the first thing you do? Construct your hypothesis test. H0 is always assumed to be true, right? So you're doing an hypothesis test based on average. So mu is equals to 10, right? Okay, why is this? It's your null hypothesis. It's always assumed to be true. Okay, so your H1, which is your alternative hypothesis, is mu. What are you claiming? What do you believe? It's higher. So this is greater than? Right. Okay. So obviously you can't go to each and every household and ask them the amount of electricity they use, maybe per day or per month. Right. So the better way to do this is just to take the sample of 30 households in this case. And from this, right, you want to make your conclusions about the population, right? Because these are parameters in the population, right? Okay, so what's the next step? Calculate your test statistic from your sample. So what are you going to use, Z0 or T0? Z0. Why Z0? Okay, N is greater or equals to 30 and variance is known. Okay, so X bar is? What is your X bar, your sample mean? What? Minus? All divided by? Now what is the standard deviation based on the population? You said it's known, so it is? 310 all divided by the square root of 30. Right. Now from this, what do you assume about your test statistic? It needs to be positive. Okay. So if you can have a greater than here and you calculate a test statistic which is negative, it means you're missing something out. Okay. So what is your test statistic? 1.77, right? Then critical region. Your critical region now, right? Obviously, if your test statistic is based on your Z0, it means that your critical region will be on the normal distribution curve. So you've got this curve. Whereabouts in this curve? On the right. Why? Because your alternative is on the right. You're dealing with the one-tailed test, so you only have one side, which is the rejection region, right? This is Z alpha by 2. This is Z 1 minus alpha by 2, right? What is your alpha? 0.02, okay? So that means 1 minus 0.02 over 2 is equals to 0.99. So what is your Z under this alpha? Is 1 point? From your Z tables, selected percentiles? 2.326, right? Again, if your test statistic is positive, you will assume that your critical region is also positive. Because it wouldn't be fair, your critical region is negative and this one is positive, your test statistic is positive. So why do you do the test if you already know that you'll reject H naught? So it's not fair, right? So it means your rejection region is this and your test statistic is this. We go to our rule. I will reject H naught if my test statistic is greater than critical region. What is your test statistic? 1.77 greater than, what is your critical region? 2.326. Is this number greater than this? Do not reject H naught. Right? Now, it doesn't stop there. These guys that fund the company, ESCOM, they don't understand this language of statistics. So you can't just say, do not reject H naught. You need to conclude. Now, what is your conclusion? What is your conclusion? There is sufficient evidence to? What did you say? Do not reject H naught. There is insufficient evidence to conclude that H1. To conclude H1, right? To conclude that the average usage of households is greater than this, right? So that's what the HODs, the people that fund companies, understand, right? Okay, this is chapter 8, right? Did you do type 1 error or type 2 error? Which error can you do, right? Which error can you do? What did you say? You said do not reject H naught, right? So the error that you can make is you're not rejecting H naught, but H naught might be false, right? That's an error you're making, right? Okay. Now let's look at chapter 10. Let's look at chapter 10. Chapter 10. Can you guys see?
Yeah.
At the back. Yes, question? Okay, chapter 10 is based on linear regression. Linear regression. Right. What comes in, the first thing that comes into your mind, the first time you see the word linear, it means you're dealing with a straight line, right? Linear, a straight line. Straight line, right? Now, what is the equation for the straight line? Can be y is equal to mx plus c, right? Where c is your cutoff point, okay? Now, what is a linear regression? A linear regression is a model. It's a model which is used. This is a model which is used to check or to measure the relation between your independent variable and dependent variables. Right, where your independent variable is x and your dependent variable is y, right? So y depends on x, okay? I mean, it doesn't stop there. I mean, it's linear regression. So your aim, you're just checking a linear relation between these two variables, independent variable and the dependent variable, right? I mean, in this case, you're only checking for the linear relation between two variables, which is independent and dependent. Okay, some variables you can find that they've got an exponential relation, right? Okay, but we'll get to that. Then you've got this, right? Now, what are these? These are your y axis. These are your x axis, right? Okay. Your y axis are your dependent variable. Your x axis are your independent variable. Now, so what does that mean? Y depends on x. If x increases, y increases. If x decreases, y decreases, right? So you've got a lot of variables. Right. This is all the x's. x1, x2, x3, x4. Let me make an example. You wanna check whether is there a relation between what you eat and your weight, right? It's a real life problem. You wanna check is there a relation between what you eat and your weight, right? So obviously you eat different things, right? Right. Some eat veggies, meat, a lot of things. We eat a lot of things. So those are your x variables, right? Your independent variables. So x1 up until xn, right? So you want to check the relation. Is there a linear relation between what you eat and your weight? So what do? You draw a line called the line of best fit, right? The line of best fit, can you see it's linear? So the equation for it is y is equals to bx plus a, right? Where b tells you the slope, right? How steep is this line, right? If b is negative, what does it mean? It means that it's from this direction, right? Okay? So this is a slope. Again, this is your cutoff point. Right? Can you see that this line can go all the way and cut the y-axis, right? So if you want to find the y-intercept, which is the cutoff point, you need to make x be equals to 0, right? So if x is 0, can you see that you're only going to be left with a, and a is equals to y, which is your cutoff point, your intercept. Then what else? What else do you need to understand? Now, you've got things called correlation coefficients, right? Which is R. R is the correlation coefficient, right? You also have R squared, right? If R is equals to 1, what does it mean? It means that your x variables are just on top of this line, the line of best fit, right? So R tells you how close are your x variables to the line of best fit, or how far are your x variables to the line of best fit, which is this line, right? So if R is equals to 1, it means that these x variables are just on top of this line. Then what does it mean about the relation? There's a strong relation between your independent variable and your dependent variable, right? So what you eat determines your weight. Okay? What if R is equals to -1? Right? There's also a strong relation between your dependent variable and your independent variable, but on an opposite direction, right? which is nice. So what does R squared do then? Everything in stats that has a 2 on top, denoted like this, chi 2 or R squared, that has a 2 here. This is what tests the variability. Right? Right. Now fine, you're telling us that there's a strong relation between what you eat and your size, right? Your weight, right? But also, can you tell us, is there a relation between these variables now? What you eat. Is there a relation between veggies and your meat? Right. Then you talk of variability. So variability, this is when you want to check the relation between amongst your variables. Right? This is to check the relation based on your variables. Right. Then this is chapter 10. Right? So let's do questions. 2015 main exam, semester 1. If you scroll down, up until which question? 48, right? You're given your x variables, you're also given your y variables. You're being told which of the following is true, right? Now, the first thing you need to do is to calculate your R squared, right? How do you do that? You use your calculator. Use it. So, use your calculator to calculate your R squared. Who doesn't know how? Raise your hand. This is a word fast. Raise your hand. Oh, come on. Shift mode. Not shift mode. Mode 2. Then 2 again. Then you put right. So what is your R? What is your R? R is equal to 0 point? 0 point? 0.95, right? What is your R squared? 0.9. Okay. Okay. Then 0.9. Then what's the correct answer then? Right? So if you look at these questions, R squared 0.9, meaning that there are approximately 90% of variation, right? We're fine with that. In the market, that's X, can be explained. Is it X? No, that's Y. Can be explained by a linear relation with the city council's valuation, which is X, right? That is also true. That is true because if you look at this equation here, y is equal to bx plus a. The y is explained by x, right? Not the other way around. So a is correct. Okay? So the following question is 49, right? So if you look at question 49, at least the least square regression line to predict the market value is. Now they want you to find this equation here. You can calculate your B, you can calculate your A, right? Okay. What's the correct answer? Again, you use your calculator. Then question, okay, what's the answer for question 49? Is? It's D. Okay. Now what is the cutoff? Same question. What is the cutoff? What is the value of the cutoff? is minus. Yes, yes. What is the slope?
6.1.
Nevutiwe beni prepared. Question 50. Let's look at question 50. You're given now this line and you're being asked a question based on million tons whatsoever. You just take this 12, substitute it in x, then you're good to go. Right? This question is the same question like you're given this line, the equation for this line, right? Mm-hmm. Can you see that every time you draw this line there must be an error, right? Meaning it's a continuation of this. So what if I'm asking you now, let's say your y value, the last value under y value is 9, right? Under x value maybe is 10, right? Now what if I'm asking you the relation of the same thing but now given x as being 10 million, right? What do? Just take the equation of this line and take 10 million as your x, you substitute an x, then you'll find the y value for it, right? That's chapter 10. Okay? So now let's play a game called Kahoot game. It's quite interesting. It's an interesting game. This game will be based on chapter 1. And I'll then later on give you another game, but this other game will be based on chapter 2, right? Okay.